Friends, chemical reactions and the corresponding balanced chemical equations are expressed in terms of the number of moles of each of the reactants and of the products. Understanding the concept of mole is the basis for understanding the chemical reactions and equations and the units of concentration of a substance. In this video, I shall discuss the concept of mole. In order to understand the concept of mole, we must understand what is Avogadro's number or Avogadro's constant. Avogadro's number is defined as the number of atoms in exactly 12 grams of carbon, that is C12 isotope. The value of Na is found to be equal to 6.022 multiplied by 10 to the power of 23. It is approximated as 6.022 multiplied by 10 to the power of 23. That means mass of 6.022 times 10 to the power of 23 atoms of C12 is equal to 12 grams. Therefore, the mass of a single C12 atom is extremely small. You can see here the image of carbon. Avogadro's number is defined with respect to C12 isotope, and this is the basis for the modern scale of relative atomic masses of other elements. For example, consider sodium. It has a relative atomic mass of 23 units. It is the latest unit that replaces AMU. That means mass of 6.022 multiplied by 10 to the power of 23 atoms of sodium is equal to 23 grams. Relative atomic mass of any element is the atomic mass of the Avogadro's number of atoms of that element. The relative molecular mass of a molecule of any compound or an element is the molecular mass of Avogadro's number of molecules of that compound or element. We have seen that an atom or a molecule has a very small mass. However, the experiments are done with measurable quantities of chemical substances which contain a very large number of atoms and molecules. It is therefore convenient to group atoms or molecules in counting units of Avogadro's number to measure the chemical amount of any substance. One of these counting units is called a mole. The origin of mole is the Latin word moles, meaning a large mass. Let us define now mole. 1 mole of a chemical substance is the amount in grams that contains Avogadro's number of atoms or molecules or ions or electrons. Mole is the SI unit of the amount of a chemical substance. It is abbreviated as MOL mole while mentioning the molar mass as grams mole inverse. Let us see. 1 mole of C12 contains 6.022 multiplied by 10 to the power of 23 atoms of carbon 12. That means mass of 1 mole of C12 is equal to 12 grams. That is atomic mass of C12. Similarly, 1 mole of sodium 23 contains 6.022 multiplied by 10 to the power of 23 atoms of Na23. That is, mass of 1 mole of Na23 is equal to 23 grams. This is relative atomic mass of Na23, that is 23. Now, you do this exercise. What is the mass of 1 mole of copper atoms? What is the mass of 1 mole of zinc atoms? Suppose we use the chemical amounts less than 1 mole. How to calculate the number of moles? For example, the amount of carbon used for burning is 6 grams. Calculate the number of moles of carbon. So 12 grams of carbon is equal to 1 mole of carbon. Therefore 6 grams of carbon, how many moles? Very simple. You can work out. It comes to 0.5 moles. Then this is the formula, general formula. For the amount of chemical substance in moles is equal to weight of the substance in grams, that is G, upon molar mass of the substance in grams mole inverse. This is applicable for atoms, elements, and molecules of elements and compounds. Now, we must know the difference between relative molecular mass and molar mass. Relative molecular mass is the sum of the relative atomic masses of all the elements present in a compound. In a molecule of the element, it is obtained by multiplying the relative atomic mass by the number of atoms in the molecule. The unit is U. When we consider the number of moles of an element or a compound present in certain quantity in grams, we use the molar mass with the unit grams mole inverse. Now let us consider this problem. How many moles are present in 10 grams of oxygen molecule O2, given that relative atomic mass of oxygen atom is equal to 16. Now when you consider the molar mass of oxygen molecule O2, that becomes 32 grams per mole, because O2, 2 atoms of oxygen. Weight of chemical substance is equal to 10 grams. Then number of moles of oxygen in 10 grams by 32 grams mole inverse, you get 0.3125 moles. Now calculate the mass of 0.2 moles of H2O. Molar mass of H2O is equal to 18 grams mole inverse. Given number of moles of H2O is equal to 0.2 moles. You can apply this formula and ultimately you can get it as mass of 0.2 mole H2O is equal to 18 grams multiplied by 0.2, that gives you 3.6 grams. Now another problem. Consider 10 grams each of copper, zinc and sodium. Find out which metal has the largest number of moles of atoms and which one has the smallest number of moles of atoms. Relative atomic masses are given here. For sodium 23U, copper 63.5U, zinc 65.4U. We must convert the amount in grams into number of moles for each metal. For sodium, it is 10 by 23 grams mole inverse. That gives us 0.4348 moles. For copper, 10 grams upon 63.5 grams mole inverse. That gives us 0.1575 moles. In case of zinc, 10 grams upon 65.4 G mole inverse. That gives us 0.1529 moles. So therefore 10 grams of sodium has the highest number of moles and 10 grams of zinc has the smallest number of moles of atoms among these three. Therefore, even though the amount of the chemical substance may be the same for different substances, if you consider, the number of moles will be different because the molar mass is different from one substance to another, one compound to another compound. Now let us consider another problem. Calculate the number of moles of copper sulfate present in 100 grams of the substance. Given that relative atomic masses of Cu, S and O are 63.5U, 32U and 16U respectively. First you have to work out the formula for copper sulfate, that is CuSO4. Then you have to calculate the molecular mass of CuSO4. Here 63.5U for copper plus 32U for sulfur plus 16 multiplied by 4 for oxygen because it is O4. Then it is 63.5U plus 32U plus 64U. It gives us 159.5U. So molar mass of CuSO4 is equal to 159.5 grams mole inverse. Then we can find out the number of moles of copper sulfate, that is equal to 100 grams upon 159.5 grams mole inverse. That gives us 0.627 moles. Now self-assessment quiz, that is for formative assessment. Choose the correct option among the 4 options in the following questions. Question 1. Which element of the following is chosen as the reference standard to determine the relative atomic masses of other elements? Option A, C13 isotope. Option B, H2. Option C, C12 isotope. Option D, O16. Question 2. Which is the SI unit for the amount of the chemical substance among the following? Option A, C12 isotope. Option B, molar mass. Option C, atomic mass. Option D, mole. Question 3. An aqueous solution of 1000 ml contains 4 grams of sodium hydroxide. What is the number of moles of sodium hydroxide? Option A, 0.04. Option B, 0.004. Option C, 0.1. Option D, 0.01. Question 4. What is the number of moles of water in 1000 grams of water? Option A, 55.65. Option B, 55.56. Option C, 56.56. Option D, 56.65. Then question 5. Consider 100 grams each of NaOH, NaCl and HCl. Which is the correct order of number of moles of each of these substances among the given options? Option A, NaOH greater than NaCl greater than HCl. Option B, NaCl greater than NaOH greater than HCl. Option C, HCl greater than NaCl greater than NaOH. Option D, HCl greater than NaOH greater than NaCl. Now, suggestions. If you have understood the concept of mole, you can answer all the above questions correctly. In case if you find any difficulty in answering any of the questions, watch the video again and again till you are able to answer independently. Practice answering many more unknown problems related to the concept of mole independently. Then only you will be able to master the knowledge of mole and its use in chemistry. Applying the conceptual knowledge is more important than simply remembering things. I wish you the best of all your efforts, my dear students.